morning, calculus friends. I just realized that we did not make you your video, and it's 8:25 this morning, so welcome to Monday morning last minute average value theorem video. Now, average value theorem is exactly what it sounds like. It's going to let us calculate the average value for a function. Okay? There's a real nice geometry interpretation of this. I actually suck at explaining it, but I will be posting a nice video about it so you can see that, so somebody else who's much better at explaining things can let you know about it. I tend to focus on sort of just the formula part of this, and the big thing I want to emphasize first off is average rate of change, average value, two totally different things. And I heard Mr. Walter say this in another video. In our course, when we say average whatever, we mean average value. If we want average rate of change, we're going to say average rate of change. So if it's average velocity, that's average value of the velocity. Average temperature, average number of cookies, average speed, average whatever, you're going to do the average value of that thing. Okay. And so notice we've got the two different questions right here. The average rate of change of f of x on -3 to 3 would be f of 3 minus f of -3 over 3 minus -3. Okay. So remember, average rate of change is like algebra slope, y2 minus y1 over x2 minus x1. However, the average value of the function is the average value calculation formula. And so that's 1 over b minus a times the integral from a to b of f of x dx. And if you think about it, you're accumulating, you're adding up all the function values from a to b, and then you're dividing it by the interval from a to b. Multiplying by 1 over b minus a is like dividing by b minus a. And so in this case, this would be 1 over 3 minus -3 times the integral from -3 to 3, integral from -3 to 3 of x squared minus 2x plus 3 dx. Okay. So average value is an integral calculation. Average rate of change is just a ratio. Okay. Average rate of change, explicit, tells you what to do. Average whatever, anything except rate of change, average of value, average blah, blah, blah. You attack it with the average value formula. Okay. Now, thanks to the magic of video, I was able to pause there and go find my key to make sure that my arithmetic is going to be correct. All right. So I'm not going to show all the steps. You should be able to crunch out the arithmetic of f of 3 and f of -3 into the f of x function. And so we should end up with 6 minus 18 over 6, or -12 over 6, or -2. Now, question B is a lot of fun. Let me throw a dual page on here. Okay, so this is going to be 1 over 6 times the integral from -3 to 3 of x squared minus 2x plus 3 dx. Now, if we say work this out using fundamental theorem, that means you've got to show your antiderivative and show all your steps. If we say throw it in your calculator, you can throw this in your calculator. You should be able to write your antiderivative though. X cubed over 3 minus x squared plus 3x. That's going to get evaluated from -3 to 3. And then times 1/6 or divided by 6. And I am not going to go through the painful process of writing all these numbers down. You can work the arithmetic yourself. Correct answer should be 6. Okay? So, every average value problem really is the same question. It's just a matter of knowing the average value formula. The biggest thing about average value is that f of x has to be continuous over a to b to find the average value from a to b. Okay. So that could be, I don't know if that's necessarily a trick question, but that could be a trick question is, you can't apply the average value theorem and average the values together if you're not looking at a continuous function over the interval. It doesn't have to be continuous everywhere. It just has to be continuous over the interval where you're looking for the average value. Okay. Why don't you go ahead and try number 2? So this would be a good place to pause for yourself. Okay. Looking at my other things going on. I'm trying to do this quick. Okay. So hopefully you wrote 1/2 times the integral from -1 to 1 of x to the 2/3 dx. So this would be 1/2 times 2/5 x to the, actually not 2/5, I apologize. This is what I get for not looking down at my key from -1 to 1. This would be a really good question to ask you to do by hand because the numbers are not terribly difficult. So we end up with 3/10 times 1 to the 5/3 minus -1 to the 5/3. This is a good one where you might think it's equal to, where am I? Oh, because I forgot the half. I'm looking at my key and I'm realizing there's a mistake on it. Awesome. So I'm looking at my key. Here, let me finish this. So final answer should be 3/10. My key says 3/2 because what did I forget? That's probably the biggest mistake that we make in average value is forgetting the 1 over b minus a. Okay. All right, let's let that be the first video for you. I'm going to go ahead and stop this and let us get this posted, and then I will put part 2 together where I will do a couple more of the problems in the packet. All right. Average value, you should at this point though go ahead and try at least 4, 5, 6, and 7, and then number 3 is a little bit of fun. So 3, 4, 5, 6, 7 would be good for you to attack. See what you can do going forward, and then I'll come back and do a couple of the trickier ones. All right, happy Monday, everybody.